Hi, good morning. Good morning. How are you today? You excited about today's lesson? Yeah, today we'll be looking at the reaction of acid and base together. I know we've looked at this before in our year 10 class when we talk about neutralization reaction, but in this class we'll be looking at the practical process by which acid and base are mixed together to get a neutral solution. So you see it's a neutralization reaction. So we'll be looking at the laboratory setup. There's a laboratory setup that is required for this reaction to occur because acids are usually solution and alkalis are also solution, and they are both colorless solutions. When they are mixed together, you get also a colorless solution. So there needs to be a method by which we can realize when this reaction has occurred. As you see in this picture, acid has been given a different color and a base a different color, and when they mix together you get another color. But this usually is not the case in the lab. Acids are colorless solution, and solution of alkalis are also colorless solution. So we're going to be looking at how this is achieved using laboratory setup. Are you ready? Come on into the lesson. So here we're going to look at the procedure of titration. So we have the apparatus setup. These are the solution, the wash bottle, that's the indicator for the titration. We have the pipette filler, the conical flask. Now these are two different types of pipette filler, okay? And I think he's going to use the more easier one to use, which is the one in black. So that's a pipette filler, an alternative to using your mouth to suck, which is the common way you will have seen before or heard of. So instead of using your mouth to suck the solution, the base is going to use a pipette filler to fill the alkalis into the pipette and then put that in the conical flask. So it's trying to pipette the solution of base, that's an alkalis. In this case, sodium hydroxide from the beaker into the pipette. Doing this procedure in the lab, it is quite important that you take note that the solution gets to the graduated mark. And this is a 25 ml pipette filler. And then what he's trying to do is to make sure that solution being pipetted is at the graduated mark, the correct mark, taking note of the lower meniscus. We'll look at this before and explain what the lower meniscus is. So you prepare the solution from the beaker into the conical flask, where it to be titrated against the solution of acid in the burette. So this is 25 ml of sodium hydroxide, and the indicator used in this titration, as you have seen in the video, is phenolphthalein, which is suitable for actually this is titration of strong base versus a strong acid. So any indicator is suitable. So phenolphthalein or methyl orange or methyl rod could be used, or a solution of litmus if it's prepared. So right here we have the filter funnel through which the acid will be added into the burette. So the acid solution is being added into the burette using the filter funnel, and then from the burette the acid will be titrated against the base. In some cases it's called a titrant, yeah, because the solution in the burette is called a titrant. So that's the one that has usually have the known concentration. So we add drops of the indicator, 2 to 3 drops is fine. So in this case I added 2 drops, and then you can see the solution, the alkali solution has gone from being colorless to sort of purple. Then you add from the burette and stir, continuous stirring. Now the idea of titration is that you have the first one as a rough, which gives you an idea of how much volume of acid is required to neutralize this base. So you can see it has changed, that means the neutralization reaction has occurred. But because this is the first time, you can see noting the approximate amount of acid used. Then a second titration is run, in which case the process is altered for you to carefully note the amount of acid required, so that when you're approaching that mark, you take caution to add in drops, so that by a drop, as you can see here, is still adding and is stirring, but at a point in time when you see that he is about to get the same volume that changed the first time, carefully add in drops, so that you will be able to find in drops the last drop or 2 drops that really change the base, that really neutralize the base. Now it's adding drops to get the exact amount of volume of acid that is required to neutralize this solution. So that's how the titration process is carried out. Thank